Good morning, children. Today, physical science second unit. Okay, physical science in first lesson. What is measurement? Okay, next, physical science second unit. Forces and pressure. Forces and pressure. Okay, now learn about that. What is forces and what is pressure? Listen. Introduction. Every day you can observe bodies around you. When you are coming to school, you can notice that some of them are moving, some of them are at rest. What pushes or pulls them? What brings the moving bodies to rest? What is the effect of the pulls or pushes? Okay. All the above questions can be answered by saying just one word, which is force. Okay. Every day you can see observe the bodies around you. See some of them rest, some of them moving. Okay. So you can find out which one push or which one pulls. Whatever push or pulls, that is only called forces. Now let us study about the what is force. Observe the following action in day-to-day life. Opening up a pen, opening a door, kicking the football, striking a carom coin, making of chapatis, etc. All the actions need a force. All the actions need a force. Force is an action of pull or push or pull. Okay. Force is an action of push or pull, which makes the bodies to move or brings the moving bodies to rest. It even changes the shape and size of the certain bodies. Okay, this is only force. Force is an action of push or pull, where which makes the bodies to move, which makes the pull. If you give a pull or push, it makes the bodies move, otherwise bring to the moving bodies to the rest. It even changes shape and size of the certain bodies. Listen, one activity. Make your two groups of students and let them stand along the straight line, one behind the other on the playground. Start the game of tug of war. You know that. With a rope. Observe the movement of the students. Who are the winners? See, the group of students who pull the rope with a greater force will definitely win. Okay. Which groups pull the ports greater force, that groups will definitely win. Okay. The winners are applying a greater amount of force. Okay, the winners are applying a greater force. யார் ரொம்ப அழுத்தம் கொடுத்து வேகமாக இழுக்கிறாங்கன்னு என்ன பண்ணுறோம், ஆப்போசிட் டீம் எல்லாம் என்ன ஆயிடுவோம், நம்ம சைடு வந்து அவங்க விழுந்துருவாங்க. தட் இஸ் கிவ் யூ கிரேட் ஃபோர்ஸ். Hence, a rope moves in the direction of the greater force. Okay. Definition of force. Definition of force. Force is that which changes or tends of change. The state of rest or the state of uniform motion of the body, the direction of moving the body or shape of the body. Okay. Force is that which changes. Forces changes or tend to change. What and all change? See, the state of rest. The state of rest. The state of uniform motion of the body. Okay, wow. The state of rest, otherwise the state of uniform motion of the body. Next, the direction of a moving body or shape of the body. 4. Pushes and pulls are forms of forces. The direction of a force is in the direction in which a push or a pull is applied. Thus, force is a vector quantity. Force is a vector quantity which has magnitude and direction. It measured with the unit called Newton. Okay. Forces. It is means what? Force. Force is measured with the unit called Newton. For symbol capital N, but you have to write it means small n, but it mentioned capital N. Next, factors on which a force depends. You have studied the effects of the force so far. Now you are going to study the factors on which of the effects of your force actually depends. When you play on any game, the greater of the force you apply on the body, greater will be its effect on it. Am I right? Just observe the strokes of the bat by the batsman. If he wants to hit the cricket ball to the boundary, the striking force on the ball must be greater. That is only fact. Force. It will give more force means ball. It gets sixer or cross the boundary. That is, they give you a force. If they give you more greater force give to the ball. That's why ball it's moving. Now the question before you is doesn't depend on the area is impact. See activity. Fix a matrix of a sharp pins on a wooden board of a row and columns. Take a big balloon, blow up the balloon. Next, place it gently over the pins. Place the small book on the top of the balloon. Will the balloon burst? Will the pins prick the balloon? See, inference, what we see. The wonderful sight of to see that the balloon will not burst. Will not burst. How it is possible? Reason. If you prick the blown up balloon with a simple pin, it will burst. But if you break the balloon, blown up a balloon with a single pin, it will burst. But now it's not a burst. Why? This did not happen even though many more pins were pricking the balloon. A single pin produces a large pressure over the small area. Okay, wow. A single pin produces a large pressure over the small area. But when we large number of pins prick the body, each pin exerts very little pressure on the balloon. Can you understand? When the blow of the balloon, you prick the balloon means balloon will burst. But number of pins, it can't burst the balloons. What is the reason? A single pin produces a large pressure over a small area, so it will burst. But when a large number of pins break a body, each pin exerts very little pressure on the balloon. As the applied force gets disturbed over a large surface of the body, so the balloon will not burst. Can you understand? We conclude that the effect of the force depend on the magnitude of the force and the area over its acts. Okay. Next class we will discuss about that next topic. Okay.